Question 1 starts off with a perpendicular bisector. Now, if we remember, a perpendicular bisector, is a combination of two perpendicular lines, and I know the lines are perpendicular because I have this right angle here, okay? And a bisector cuts a line segment into two smaller congruent pieces. So, and that's what these little dashes tell me, okay? So that tells me that, although it's not, there's no letter here, from C to the center and then D to the center, those two pieces are congruent. And because these two triangles, I need to give this a letter. I'll call this point G, just so I can have something to reference. Triangle CDG has line DG in common. It's a side that they share. So I know that these two triangles, CDG and EDG, are congruent because both triangles have side, angle, side. And of course, this other angle is also 90 degrees because a straight line has 180 degrees, and when I subtract 90 from 180, I also get 90. So essentially, the perpendicular bisector always gives me two congruent triangles. Okay, and when that happens, that means all of the other angles and sides are also congruent. So that means that because the two triangles are congruent, that means side CD is congruent to side DE. And if they're congruent, that means their values are equal. So to solve for the length of CD is 7a plus 11, DE is 10a plus 2, and because they're congruent, they are equal. So I now have an algebraic expression I can solve. Remember, I need to get all my variables to one side and my numbers to the other. I chose to subtract 7a from both sides because then that way that keeps my variable positive. And 10 minus 7 is 3. Then I can subtract 2 from both sides. Equals 11 minus 2 is 9. My last step, of course, is to divide by 3. And 9 divided by 3 is 3. Now, you'll notice in our multiplication, our choices here, A, B, C, and D, A is 3. But remember, that is not the question that's being asked. The question that's being asked is the length of CD. Okay? 3 is not the length. 3 is what A equals. So I need to substitute 3 for A to find the length. And 7 times 3 is 21. And when I add 11, I will get 32. So do not make the mistake of not answering the question or not going back to reread the question to ensure you're answering what's being asked of you. So, while A equals 3, the actual length of CD is 32. Okay, and if you'll notice, this diagram is very similar to this diagram here. So again, And here it tells me that JK is congruent to KM, okay? Now, if these two sides are congruent, then that means these two pieces are also congruent. Because again, as I said in our previous example, we have side angle side. That proves that our, well, in this case, technically is hypotenuse leg, but either way, essentially, I have the same picture. I have a perpendicular bisector. Okay, so if if you'll notice, from here to here is 7.1. So just like in this diagram, CG was congruent to GE. So same thing here. This is also going to be 7.1. But that's not what it asks. The question asks for the length of JM. So that's the entire length of the triangle. And to get that, we need to add the two pieces together. So JM is actually 14.2. Okay. Very careful. If you would put 7.1, it would be incorrect, because that's not what the question is asking. Okay. And here, again, in this particular case, we have an angle bisector. Okay, because these little arcs tell me that my two angles are congruent. Okay. So that's what this means. M means measure. The measure of angle BDA is going to be the exact same value as the angle CDB of 23 degrees. And because these angles are congruent, that also means that these two pieces, AB and BC, are also congruent. And just like our previous example, if the two pieces are congruent, then the two expressions are equal. And we will solve this the same way. Okay, if it helps, put the equal sign, put a line down the equal sign. Subtract 4x to the left, so I have all my variables to one side. And then add 4 to get my numbers, or my constants, to the right. So 5x equals 5. And remember, we always divide by the number in front of x. So x equals 1. Okay? And again, they put the 1 here. But that is not what's being asked. Blank 1 is the length of CB. Okay? Well, CB is 4x plus 1. So when I substitute in a 1 for x, I actually get 4 plus 1, because 4 times 1 is 4, obviously. So the length of CB is actually 5. Make sure you are reading the question carefully. Okay, and number 4. This has to do with our property of triangles, that we determined that the smallest angle is opposite the shortest side. Or we can also say the largest angle is opposite the longest side. Okay, so it's asking us the angles of the triangle, are they ordered from least to greatest properly? Okay, so we're looking from, again, least to greatest. So I'm going to find I'm going to determine which side is the shortest first, so I can determine the smallest angle. Well, if the decimals throw you off, think of it in terms of money. Okay, and I can always add a 0 after the 8 so that all the decimals have, there's 2 decimal places. Okay, and $6.75 is less than $6.80. So SQ is my shortest side, and that is opposite angle R. So angle R is my smallest angle. Okay. Now my longest side, RQ, at 10.54, that's going to be my longest side, obviously, and that is opposite my largest angle, which is angle S. And of course, what's left in the middle between the shortest and the smallest is RS, and RS is opposite angle Q. So this is the correct order of both of the angles and the side lengths. So is it true that the smallest angle is angle Q? No, of course not. It is false.